Okay, today we are doing lesson 59, dealing with experimental data. All right, if you guys are used to an equation that we've got, say y equals 2x plus 3. All right, this is a linear equation, so if I graphed it, it would, show a line. It's a linear equation in two unknowns. I have a variable x and I have a variable y, and we use this in real life scenarios, and you guys are going to see it in advanced math. Say you're involved in a lab experiment. In our lab experiment, we would collect data, and we can take that data and we can graph that data. All right, so say we've got something that we're doing here. All right, and we have bronze. All right, and we have copper. All right, and the bronze, okay, for both of these, our units are going to be kilograms. All right, and as we're looking at the bronze, say we've got, down here 5, up here we've got 40. All right, and as we're over here looking at the copper, let's say we've got over here 5, over here, say we've got 15. All right, and we've got these various and sundry data points that are going to kind of come in this area here. All right, so what we would wind up needing to do is to go ahead and draw a line that just kind of approximates where these are landing. All right, and as we drew our line, we're going to go, notice here, okay, say I've got a point right here, and say that I've got a point, basically up here, and I'm able to see that I can now take this and I can draw a triangle. I draw a triangle here, and I draw a triangle here. All right, I can see this distance over here is 10. All right, to go from 5 units of copper to 15 units of copper. And over here, I go from 5 units of bronze up to 40, so this distance is 35. By the way, you'll often notice that the scale is going to be different on the two different sides. It's not necessarily going to be the same. All right. But look at here, we've got this. So I can still take with this line, what you're going to have, you're going to get these different dots, and you're going to need to draw your own line. And it's not going to be perfect. All right, but you're looking for things that come out close, because this is how it's going to be in the real world. So we're going to have our data, and we're going to graph our data. We're then going to estimate where the line is going to be, and then we want to be able to write an equation for that line. All right, and if we look here, I can see I've got my y equals mx plus b, right? All right, so over here, my y-axis is bronze. All right, m is going to be for my slope. My x-axis is copper, so we're going to put the cu in there. Cu in for the copper, and then there's the B. Okay, so if I look at my slope, my rise is 35, my run is 10, so I can go ahead and put that 35 tenths in there. All right, and then I'm going to look for a point that I can find. If I had drawn this a little bit better, I might decide that, one point that I can work with is this point right here, and say this point is roughly 15 on the x-axis and 40 on the y-axis. So I can go ahead and I can plug the 15 in. Okay, let's say the 15 on the copper axis. So let's plug in this 15. All right, and over here on the bronze axis, we've got the 40. So I'm going to plug the 40 in here. So we've already done this in previous problems. And here we're solving for the B. We're solving for this y-intercept here. All right, so now as I work that math problem out, multiplying 35 times 15, dividing it by 10, all right, I'm going to get that 40 equals 52.5 plus B, and that B then equals negative 12.5. So now I can write this equation for this line. I've got a slope and I've got a y-intercept now, right? Okay, so now this is going to be B equals 35 tenths CU, and not plus, but minus 12.5. Okay, so this is going to be the equation of the line that I'm looking for. All right, I found my slope by finding 2 points on my line, and you're going ahead and figuring out what is the rise over the run. I found my intercept by taking that slope that I had and picking a point on the line and entering the two values for that point, and that's how I was able to solve then for my intercept. Okay, let's do another one. All right, this time, here we go. We're going to have nitrogen. Okay, and let's say we've got 2, 4, 6, 8, and 10. And over here, we're going to have 10, 20, 30, 40, and 50. And this is going to be sulfur. Okay. And we are going to have some data points that are going to kind of go scattered in this area here. Actually, I wanted it to kind of run off this way a little bit more. Okay. So let's take these out. Okay, so here we have these data points. So now I'm able to take right here and draw a line in that area. Okay, and so as I've drawn this line, I'm able to see my rise over run. Okay, noticing right here, I'm going basically from that 10 to, okay, this doesn't really, let's say this doesn't necessarily come over quite that far. This comes over here from the 10 to the 45, so the distance right here is going to be 35. All right, and this right here is going to go from down here, this is a little bit below the 2, and say that it comes about up to right at the 8. Let's say this that's about where my data point's in. So I'm looking at this length right here, okay, and going again from a little bit below the 2, basically up to the 8. And let's say that I found that this was 6.4. Again, this is kind of some rough estimating that we're having to do here, all right? So I see this, and I decide also that, okay, there's a point right down here that works. And let's say this was all just a little bit lower here. Okay, sorry, this is not perfect. Again, this is really not going to be perfect. I'm trying to work with the numbers that I had. Okay, say that my line looked a little bit more like that, okay? So I've got a point right here that I feel like I can go with, and this point is going to be 10, 1. Okay, it's 10 on this axis, and say it's 1 down here on that axis. Okay, so as I'm looking at this, I've got my equation. My y is going to be nitrogen equals a slope times my sulfur plus my intercept, right? Okay, so as I look at my slope here, my slope, rise over 1, I'm going to rise up 6.4. I'm going to run over 35, right? Okay, say I like this point down here. All right, so on the y-axis, on the n-axis, it's up 1, so I'm going to put a 1 in there in place of the n. Okay, over here on the sulfur axis, it's over 10. So I'm going to put a 10 in there for the s. All right, put the b, and I'm going to solve for b. So I get 1 over here. Let's say I went ahead and divided the 6.4 by 35. That's going to give me 0.18. I'm going to multiply that by 10 plus b. So 1 equals 1.8 plus b. So subtract that 1.8 from each side, and I'm going to get negative 0.8 equals b. All right, so now what my job was to write an equation for this line right here. So the equation for the line is going to be nitrogen equals negative 0.8 sulfur. Nope, not 0.8. Sorry, guys. Equals 6.4 over 35 sulfur minus 0.8. Put my number in the wrong spot. All right. So we were given what will happen with these problems. You will be given a graph and it'll have the data points on it. All right. So that's going to be there already. They're going to give you the chemicals that are involved in the experiment. You're going to need to draw a line. You're just going to estimate a line. All right. And when you do that, you want to kind of do it to where you're going to have a definitive point in there that you can work with. So kind of draw that line as best you can to where you have a definite point that you can work with. You want to figure out the slope of the line. Use that slope of the line, and then you want to have that one point that you can feel like, okay, here's a good solid point that I have, and you plug that good solid point into your standard equation, your standard slope-intercept form equation, in order to be able to solve for the intercept, and then you can put together your full equation. Okay? All right, there is one more concept here in 59. Actually, there's a couple of more concepts in 59. Okay, so here we go in chapter 59 as well. This is going to be solving simultaneous equations. All right, so here I have, and we've done something similar before. We've solved systems of equations. So say I have these two equations. I have x over 2 plus 3y over 5 equals negative 2/5. It's going to be equation A. All right. And then equation B is going to be 0.06x minus 0.2y equals 1.04. Okay, and I've got this system of equations here. All right, and we want to solve that. Okay, so what we want to do, we want to eliminate the fractions, we want to eliminate the decimal points, and then we can start comparing things. All right, so let's look here as we've got this first one. X over 2 plus 3y over 5 equals negative 2 over 5. All right, my common denominator would be 10, so let's multiply everything by 10 so that we can eliminate the fractions altogether. So this 2 and this 10 are going to cancel out to be 5. The 5 and the 10 are cancel out to a 2, and the 5 and the 10 will also cancel out to a 2. So 5 times x will be 5x, plus 2 times 3y is going to be 6y, and this is going to equal negative 4. All right, let's look at this other equation that I have here, this 0.06x minus 0.2y equals 1.04. I need to move my decimal point. Okay, this is going to be my smallest number here, this 0.6. I'm moving it 2 spaces, basically multiplying it by 100. So I need to do that with everything. I'm going to take and multiply this by 100. Multiply this by 100, and I'll be multiplying this by 100 as well. So when I do that, I'm going to get 6x minus 20y equals 104. So now I can just take these two equations and work with these two equations. So my two equations now, 6x minus 20y equals 104. All right, so these are what I'm working with. So now it's just the idea of using either elimination or substitution. All right, so let's take and multiply this one by negative 6. Let's multiply this equation right here by 5. Okay, so there, the negative 6 times 5x gives me negative 30x. Negative 6 times 6y gives me negative 36y. And then the negative 6 and the negative 4 is going to give me 24. Down here at the bottom, I'm going to get 30x minus 100 y equals 520. All right, add those two together. My x's are going to cancel out. I'm going to get negative 136y equals 544. Divide both sides by that negative 36. I'm going to get that y equals negative 4. All right. I can come over here with this equation. This 5x plus 6, let's plug in the negative 4, equals negative 4. 5x minus 24 equals negative 4. 5x equals 20. And then we would say that x equals 4. So we've solved this equation that x equals 4, y equals negative 4. Okay? All right, so that's what you're doing with those. Not a big deal. They're going to give you a system of equations, and they're going to ask you to solve this system of equations. When I'm asked to solve, what that means is find the values for x and y. All right? Eliminate your fractions by multiplying them all of the fractions by the common denominator. Eliminate your decimals by multiplying all of them by 10 or 100 or 1,000, whatever you need to do to move the smallest decimal point over. All right, and then just solve the system of equations like we're used to. Okay, last thing, chapter 59 is a huge chapter. Okay, let's see, we've got totally different idea. Convert negative 5r minus 3u to polar form. Okay, so remember that this is rectangular form, and we want to change it to polar form. Okay, and remember with polar form, we're going to have this right here, and this out here is going to be the length of our hypotenuse. Okay, and this right here is the angle from due east. All right, and that was the due east was that x axis. Okay, so let's look at this. I'm going to take and draw a coordinate plane. All right, 1, 2, 3, 4, 5, and we're going 1, 2, 3, 4, 5. All right, so this is negative 5r, so 1, 2, 3, 4, 5, and negative 3u means this point is down here. So this is negative 3, this is negative 5, so my point is right here. So I'm going to be able to draw this right here. Okay, and we're looking to solve this. All right, so I want to make that triangle, remember? So here I have a triangle right here. All right, and the length of this triangle, the length of this side of the triangle here is 3, and the length of this triangle right here is 5. All right, I don't know my angle, but if you think about this angle right here, this is adjacent and this is opposite. So I do know the adjacent and the opposite, but I don't know the angle. So adjacent and opposite are going to be, I'm going to use tangent when I know the adjacent and the opposite. So we could say that the tangent of theta, this unknown angle, is going to equal the opposite over the adjacent. So that means this equals 3 over 5. So that's going to equal 0.6. So I know the tangent of some angle, the tangent of this angle equals 0.6. So what I need to do is find the inverse tangent. So this is going to be inverse tangent 0.6. All right, and we're going to find that equals 31 degrees. All right, you need to figure out how to do this on your calculator. All right, and Google is going to be your best friend. For me, what I'm going to need to do is I have to hit the second. There's a button, and it's the second button. So I hit the second button, then I hit the tangent button, and that gives me that inverse tangent. And then I hit this 0.6, and the equals, and it gives me the 31 degrees. So you monkey around with that. It doesn't actually give me 31 degrees. It actually gives me like 30.96. So you guys play around with your calculator and figure out what you need to do. So what this tells me is that the angle is going to be 31 degrees. All right, now that I have that angle, I can use that to solve for the hypotenuse. All right, so now I know I can work with the sine of 31 degrees. Remember, opposite over hypotenuse? All right, my opposite is 3. I don't know my hypotenuse, right? Multiply both sides by h. I get h sine 31 degrees equals 3. Divide both sides now by sine 31. So we're just kind of moving things around a little bit. So I'm isolating the h. So h equals 3 divided by the sine of 31 degrees. All right, so in your calculator, you're going to put that in, and you're going to get that h equals 3 divided by 0.5150. Remember, I put this in my calculator, and it gave me that. So from this, I find that h equals 5.83. So the answer to my problem now, all right, I'm going to put that my hypotenuse is 5.83 and my angle was 31 degrees. So that where I began, okay, that negative 5r minus 3u equals this over here. And that's now I've got that written in polar form. Okay. Oh, sorry, just dawned on me. Did something wrong. Sorry, guys. Remember the fact that this right here, so I just thought about that this line is over here, right? And that angle is 31 degrees right there, right? Okay. I got to add in the 180 that's over here. So there's 180 degrees there plus this 31 degrees here. This is wrong. All right, so and at my negative 5r minus 3u equals, this length is 5.83, but my the angle is actually 211 degrees. All right, that's that 180 plus the 31. Okay. Oops, don't do the same thing I just did. Actually, hopefully the fact that I did that will help you remember so that you don't mess that up. Okay? All right, that is how that is going to go for you. Let me show you one other thing real quick. We could also deal with this. Remember a squared plus b squared equals c squared? All right, I had this right here. So if I work with this, if I take the square root, all right, of each of them, then I can have that, I'm going to flip this around just to make it easier, that c equals the square root of a squared plus b squared, right? Okay, remember up here, I had this triangle when I plotted that point right there. Remember when I plotted that point, that this was 3 and this was 5? All right, and think about the fact that this is a right triangle, right? So I could use the Pythagorean theorem also to solve for that hypotenuse. Remember that c winds up being the hypotenuse. So c equals the square root of 3 squared plus 5 squared. All right, so this is going to tell me that c equals the square root of 34. All right, so I could look at this also as the square root of 34 and that 211 degree angle. All right, so I would have needed to still have used, I used the tangent is what gave me this 31 degrees. All right, so I would have still needed to use that tangent in order to get the 31 degrees. Okay, and remember that the 31 degrees plus 180 is how I get that 211. All right, but as far as solving for this number out here, I could have done it using sine like I did, or I could have done it by using the Pythagorean theorem there. All right, and I've got there the square root of 34. Okay, the square root of 34 equals 5.83, which is the same amount that we came to up here. All right, so either one of those ways work. Just another little option for you there. And that brings us to the end of lesson 59.